y equals e to the 3x, determine x when y is 10. So we're solving 10 equals e to the 3x. I can straight away write down that 3x equals ln 10. Or alternatively, you can do ln of both sides, bring the 3x down using the third rule of logs, and then ln e is just 1. We get the same answer. You could, of course, use other bases. You don't have to use ln, but it makes sense to use ln because then we get rid of the e. It's just all nice and simple. So then x will equal a third ln 10. But that is my exact answer. So I just left it like that. You could write it to three significant figures if you want. It doesn't really specify whether to write it exact or not. So 0.768, for example. For B, we're asked to determine the gradient of the tangent to the curve at the point where x equals 2. So this is going to be dy by dx at x equals 2. When we differentiate e to the x, we get e to the x. When we differentiate e to the kx, we get k e to the kx. So this is going to be 3 e to the 3x. You learn more about that in the second year using something called the chain rule, but for now it's a result that you just kind of learn, although you can show it from first principles. It's a bit complicated, but it's quite interesting as well. Anyway, that's dy by dx. So when x equals 2, dy by dx is simply going to be 3 e to the 6. And this is a gradient of tangent. Yeah, the curve and the tangent have the same gradient at the point x equals 2. So again, this is exact, absolutely fine to leave it like that. If you want to write it to three significant figures, then you would get 1,210.